Note 7D. Solving radical equations. Example 1. Radical equals constant. Solve the following radical equations. A. The square root of x plus 1 equals 6. To get rid of a square root, we will exponentiate both sides by 2. So exponentiate by 2 to get rid of the square root. Then we have x plus 1 equals 36. Subtract 1 from each side, and then you have x equals 35. We don't have to check for extraneous because there's no variables on the outside of the radical. B. The square root of a minus 2 equals 3. Exponentiate each side by 2. And then we have a minus 2 equals 9. Add 2 to each side. A equals 11. C. The square root of n minus 4 equals 7. Before we exponentiate, we need to isolate the square root part. To do that, we're going to add 4 to each side. So then we have the square root of n equals 11. Exponentiate each side by 2, and then you have n equals 121. D. The square root of y plus 5 equals 13. Subtract 5 from each side. We have the square root of y equals 8. Exponentiate each side by 2, so we square each side to get y equals 64. Let's look at E. Negative 2 times the square root of a minus 1 equals negative 4. To isolate the square root, we're going to divide each side by negative 2. So we have the square root of a minus 1 equals 2. To get rid of a square root, we square each side. We exponentiate by 2. So then we have a minus 1 equals 4. Add 1 to each side, and then we have our solution, a equals 5. F. Negative 5 times the square root of m plus 3 equals negative 20. Divide each side by negative 5. Then we have the square root of m plus 3 equals 4. Exponentiate each side by 2. You have m plus 3 equals 16. Subtract 3 from each side, and then you have your solution, m equals 13. We still don't have to check for extraneous because there's no variables on the outside of the root. G. 4 times the square root of x minus 3 equals 9. To isolate this radical, we first add 3 to each side. So 4 square root x equals 12. Divide each side by 4. You have the square root of x equals 3. Exponentiate each side by 2. And then you have the solution, x equals 9. H. 6 times the square root of y plus 2 equals 26. Subtract 2 from each side. We have 6 square root y equals 24. Divide each side by 6. You have the square root of y equals 4. To get rid of the square root, exponentiate each side by 2. Y equals 16. That's your solution. Okay, let's look at I. The square root of 3x minus 3 equals 6. The radical is already isolated, so we're just going to exponentiate each side by 2. So we raise both sides to the second power. 3x minus 3 equals 36. Add 3 to each side. 3x equals 39. Divide each side by 3. So then we have our solution, x equals 13. J. The square root of 16x plus 1 equals 7. Exponentiate each side by 2. We have 16x plus 1 equals 49. Subtract 1 from each side. So then we have 16x equals 48. Divide each side by 16. You have the solution x equals 3. K. Negative 2 times the square root of 4m minus 5 equals negative 17. To isolate this square root, first we add 5 to each side. Then we have negative 2 square root 4m equals negative 12. To isolate the square root further, we're going to divide each side by negative 2. So then we have square root of 4m equals 6. To get rid of the square root, we square each side, we exponentiate by 2. So we have 4m equals 36. Divide each side by 4. And then you get your solution, m equals 9. L. 5 times the square root of 3x plus 11 equals 56. To isolate this square root, we first subtract 11 from each side. So then we have 5 square root 3x equals 45. To continue to isolate that square root, divide each side by 5, and then you get square root 3x equals 9. Exponentiate each side by 2, and then you get 3x equals 81. Divide each side by 3, and then you get your solution, x equals 27. Page 37. Example 2. Radical equals radical. Solve. A. The square root of 3x plus 5 equals the square root of 2x plus 7. There's no square roots to isolate here. They're both already by themselves. We could square each side to get rid of those square roots. So then we have 3x plus 5 equals 2x plus 7. Solve it like a regular linear equation. Subtract 2x from each side. We have x plus 5 equals 7. Subtract 5 from each side, and then you get your solution, x equals 2. B. The square root of 7n plus 13 equals the square root of 4n plus 10. Exponentiate each side by 2. And then you get 7n plus 13 equals 4n plus 10. Subtract 4n from each side. So then you get 3n plus 13 equals 10. Subtract 13 from each side. And then you get 3n equals negative 3. Divide each side by 3, the number in front of the variable. And then you get your solution, n equals negative 1. C. The square root of negative 2a plus 5 equals the square root of 9 minus 3a. Exponentiate each side by 2. And then you get negative 2a plus 5 equals 9 minus 3a. Add 3a to each side. So there we get 1a plus 5 equals 9. Subtract 5 from each side, and then you get your solution, a equals 4. D. The square root of m plus 1 equals the square root of 31 minus 4m. Exponentiate each side by 2. That gets rid of all the square roots here. we have m plus 1 equals 31 minus 4m. Add 4m to each side. So we have 5m plus 1 equals 31. Subtract 1 from each side, and then we have 5m equals 30. Divide each side by 5 to isolate that m. And then you have your solution. M equals 6. E. The square root of negative 7 minus 8f equals the square root of 2 minus 5f. Exponentiate each side by 2. That cancels out all the square roots, and we're left with negative 7 minus 8f equals 2 minus 5f. From here, we're going to solve for f, add 8f to each side. So then we have negative 7 equals 2 plus 3f. Subtract 2 from each side, and then we have negative 9 equals 3f. Divide each side by 3, and then you have your solution. F equals negative 3. F. The square root of 14 minus 6x equals the square root of 8 minus 5x. Exponentiate each side by 2 to get 14 minus 6x equals 8 minus 5x. Add 6x to each side. And you have 14 equals 8 plus x. Subtract 8 from each side. Then we have 6 equals x. There's nothing else to divide here, so that's your solution. X equals 6. G. The square root of 3n plus 16 minus the square root of 2 minus 4n equals 0. The first thing you want to do here is have the square roots on different sides of the equation. So we're going to add the square root of 2 minus 4n to each side. Those give you 0. So you have the square root of 3n plus 16 equals the square root of 2 minus 4n. Exponentiate each side by 2 to get rid of the square roots. So you always want to have, if you have two square roots in the equation, if you can't combine them together, if they're not the same numbers inside, then you want to have them on two sides of the equation. If there's another number besides 0 here, you'll have to repeat this process twice. Then we have 3n plus 16 equals 2 minus 4n. Add 4n to each side. So then we have 7n plus 16 equals 2. Subtract 16 from each side, and then we have 7n equals negative 14. Divide each side by 7, gives you 1n, and then you have your solution. N equals negative 2. H. The square root of 8 minus 4p minus the square root of p plus 3 equals 0. Add the other square root to the other side. And then we have the square root of 8 minus 4p equals the square root of p plus 3. Now we can exponentiate each side by 2. And then we have 8 minus 4p equals p plus 3. Add 4p to each side. So then we have 8 equals 5p plus 3. Subtract 3 from each side. And then you have 5 equals 5p. Divide each side by 5, the 5 in front of the p. And then you get your solution. P equals 1. Page 38. Recall, extraneous solution is a solution that does not satisfy the original equation. It would give a false statement. Example 3. Evaluate extraneous. Find which given solution is the extraneous solution. A plus 1 equals the square root of 7a plus 15, negative 2, and 7. So we will plug these in and see which one gives you a false statement. So let's plug in negative 2 first. So wherever we see a, we're going to replace it with the negative 2. So is negative 1 equal to the square root of 1? Negative 1 is not equal to 1. So this one is extraneous. Okay, let's check the other one. 7 plus 1, is that equal to the square root of 7 times 7 plus 15? Is 8 equal to the square root of 49 plus 15? Is 8 equal to the square root of 64? Yes, this one is real. So the extraneous solution is negative 2. B. The square root of 2x plus 7 equals x minus 4, 1 and 9. Let's plug in 1 first and see if it gives you a false statement. So is the square root of 7, 8, 9 equal to negative 3? 3 is not equal to negative 3, so this was extraneous. Let's do 9 now. The square root of 2 times 9 plus 7, is that equal to 9 minus 4? Is the square root of 18 plus 7 equal to 5? The square root of 25 is equal to 5, so this one's real. So there are cases where both are real, or both are extraneous, or one real and one extraneous. Example 4. Radical equals variable. Solve. A. Y equals the square root of 5y. So we have the radical already isolated, so let's exponentiate each side by 2. So then we have y squared equals 5y. From here, let's subtract the 5y to the other side. So then we have y squared minus 5y equals 0. The GCF of y squared and negative 5y is y, so we can factor out a y. So we have y equals 0 or y minus 5 equals 0. So y equals 5 or y equals 0. Now, since there's a variable on the outside, that's why we have to check for extraneous. So we're going to plug in 0 and 5 back into the original and see if it's a true statement or a false statement, just like on A and B of example 3. So let's plug in y equals 0. So is 0 equal to the square root of 5 times 0? Yes, that one's true, so that one's real. Let's plug in 5. Is 5 equal to the square root of 5 times 5? Yes, that is also true, so that is also real. When you specify your answers on these kinds of problems, make sure that you say if it is a real solution or an extraneous solution. So we have reals at y equals 0 and y equals 5. B. The square root of 3n minus 2 equals n. So we want to exponentiate each side by 2. So then we have 3n minus 2 equals n squared. Move everything to one side of the equation. So there you have n squared minus 3n plus 2 equals 0. We want to factor this. AC is 2, B is negative 3. So we could do negative 2 and negative 1. Negative 2 times negative 1 is positive 2, and negative 2 plus negative 1 is negative 3. Divide by A, and then you have your two zeros. You have a plus 2 and a plus 1. So n equals 2 or 1. So we're going to plug those back in and see if they are true statements or not. So 3 times 2 minus 2, is that equal to 2? Is the square root of 4 equal to 2? Yes, so that's true. Real. Okay, let's plug in 1. The square root of 3 times 1 minus 2, is that equal to 1? The square root of 1 does equal 1, so that's also real. So we have two real solutions here. At n equals 1 and n equals 2. So again, they could be both real, they could be both extraneous, or you could have one real and one extraneous. Let's look at example 5. Radical equals expression. Solve. Check for extraneous solutions. A. The square root of x plus 2 equals x minus 4. We're going to exponentiate each side by 2. And then you get x plus 2 equals, let's go ahead and box this one out. We have x minus 4 and x minus 4. We have it twice because we squared it. We're going to find the area of each of these four boxes. We get x squared minus 4x minus 4x and plus 16. Combine the like terms. So there you get on the other side of the equation, x squared minus 8x plus 16. From here, let's move everything to the one side of the equation except for 0. So I have minus 1x and minus 2. So we have 0 equals x squared minus 9x plus 14. We want to factor this. A times c is 14. B is negative 9. The two numbers that work here is negative 7 and negative 2. Divide them by A, which is 1. So then we have x minus 7 equals 0, or x minus 2 equals 0. So then we have the two possible solutions, x equals 2 or 7. So we're going to plug those back into the original to see if it's a true statement or a false statement, since there's a variable on the outside of the root. So let's plug in 2. 2 plus 2, so is the square root of 2 plus 2 equal to 2 minus 4? Is the square root of 4 equal to negative 2? No, because 2 is not equal to negative 2. So this was false. So it's extraneous. X equals 2 is extraneous. Okay, let's plug in 7. Square root of 7 plus 2, is that equal to 7 minus 4? Is the square root of 9 equal to 3? Yes, 3 equals 3, so that one is real. So x equals 7 is real. So then we're going to specify our real solution and our extraneous solution. So real is x equals 7, extraneous is x equals 2. So in this case, one was real and one was extraneous. B. The square root of 3y minus 8 equals y minus 2. Exponentiate each side by 2. And you get 3y minus 8 on this side. And then let's do the box method to multiply out the y minus 2 squared. So it's squared, so we're going to have two sides that are of equal length. Find the area of all four boxes. Y times y is y squared. Y times negative 2 is a minus 2y. Y times negative 2 is a minus 2y. And negative 2 times negative 2 is a positive 4. Combine the like terms here, and then you get y squared minus 4y plus 4. Move everything to one side of the equation. So then we get 0 equals y squared minus 7y plus 12. Factor A is 1, B is negative 7, and C is 12. A times C is 12. B is negative 7. The two numbers that look like they would work here is negative 4 and negative 3. We'll divide those by 1. So we have y minus 4 times y minus 3 equals 0. So you have two possible solutions, y equals 3 or 4. So we're going to plug in both of those to see if they are real or extraneous. So let's plug in 3. We're plugging these into the original equation. So it's 3 times 3 minus 8 equal to 3 minus 2. Is the square root of 9 minus 8 equal to 1? Yes, the square root of 1 does equal 1, so that one's real. Okay, let's try y equals 4. The square root of 3 times 4 minus 8, is that equal to 4 minus 2? Is the square root of 12 minus 8 equal to 2? Yes, the square root of 4 does equal 2. So this was also true. So we have two real solutions. We have y equals 3 and y equals 4.